Today we're talking about rational exponents part 1. This is page 93 of your workbooks. This first portion we could have done as a really good investigation. Due to the circumstances, we aren't, but it would have been a really good one. So I want you to try and put on your investigation hats and you're looking for patterns. So we're still talking about exponents. In our last lesson we talked about integral exponents, and now we're talking about rational exponents. So that means we are talking about fractions. Remember, a rational number is a number that can be written as a fraction. So let's go through this first warm-up. Root 5 times root 5 is the same thing as saying root 25. That concept we're actually going to cover in our next unit a little bit further in depth. So trust me on this one for now. Square root of 25 is equal to 5. Okay, the second question says if I have 5 to the power of a half times 5 to the power of a half, we all know we can use power rule here. So here we're adding a half plus a half, which is equal to 1. 5 to the power of 1 is 5. Well, knowing those two things, these statements are then somehow related because I have these two pieces common in both, and they're both equivalent to 5. So if I kind of work backwards, we could say 5 is equal to 5. And then root 5 has to be equal to 5 to the power of a half. And that is, in fact, the rule we're coming up with. It's kind of hard, their setup of it, to deduce that necessarily, but that's what we're getting at. So let's go through this next example to really confirm this understanding. So if we start here, cubic root of 2 times the cubic root of 2 times the cubic root of 2 is the same thing as saying the cubic root of 8, which is 2. 2 to the power of a third, a third, a third, so I get a third added to each other 3 times, which gives us a total of 1. So that means 2 to the power of 1, 3 is equal to the cubic root of 2. So hopefully we're starting to see some type of pattern here. So 25 to the power of a half, I could say is the square root of 25. 64 to the power of a third, the cubic root of 64. Fourth root of 81. Let's write the following in radical form. So this would be the square root of x. Remember, square roots we can do just the check mark, or you could put the 2. Both are equally correct. The first option is significantly more common. B to the power of a third would be the cubic root of b, the 10th root of p, or the nth root of a. So our step 1, that's our first rule then, would be a to the power of 1 over n is equal to the nth root of a. That's our general rule. This gets to be a little bit more complicated. Not much, just a little bit more. So these questions, we have a root and an exponent here. So the square root of 5 cubed and the square root of 5 cubed gives me just 5 cubed. My roots cancel out, which gives me 125. 3 over 2 plus 3 over 2 gives me 6 over 2, which is just 3. 5 cubed is 125. So what that means, 5 to the power of 3 over 2 is equal to the square root of 5 cubed. So our general rule on this one, a little more complicated, if we go down here to the bottom, is a, the nth root of a to the power of m. The difference here between my first general rule and this general rule is the first one, it was 1 over n, now it's m over n. The power of 1, we don't always write, so now that's where that m comes from. So on these, this last row here, my denominator is your root, how many roots, and the numerator becomes our exponent. So this first one, I get the cubic root of x to the power of 5. The fifth root of b to the power of 4. Square root of p to the power of 5. And we already did the very last one. Okay, let's turn the page. So now let's look at it a step further, a little bit more complicated. So I have 8 to the power of 2/3. I hope you guys agree that I could take out that 2 and put it outside my brackets, because at the end of the day I would multiply that in. 2 times 1 gives me 2, and the 3 would kind of tag along, which in that case we can expand it to make it with our radical instead of a fractional exponent. The cubic root of 8 is 2. I then square that 2, and we get 4. So that's one way to interpret this one, is going through all of those steps. Okay, let's look at this one again. Different way to think about it. This time they factored out the 1/3. So now they left 8 squared in the middle and put the cubic root on the outside. Well, this is now just saying the cubic root of 64, well, that's still 4. Which means when we have these fractional exponents, we can think about them in a couple different ways, all equally correct, and frankly, depending on the question, you may want to do one over another. Okay, so let's look at 64. I could rewrite this as the square root of 64, that answer, cubed. Well, the square root of 64 is 8. 8 cubed, I do not expect you guys to know this without a calculator, but it is 512. This next one, the square root of 4, because of the 2, all to the power of 5. Square root of 4 is 2. 2 to the power of 5 is 32. Fourth root of 81, all to the power of 3. Fourth root of 81 is 3. 3 cubed is 27. Okay, so exponent law is to simplify this next one. So I'm adding my exponents. 2/3 plus a negative 2/3 gives me 0. 8 to the power of 0 is 1. So use the results in A to write 8 to the power of negative 2/3 in a form with a positive exponent, and then evaluate without using a calculator. So first off, let's write this with positive as exponents, so that means I'm going to rewrite it as a fraction of 1 over 8 to the power of 2 over 3, which from there I can say 1 over the cubic root of 8, all squared. Cubic root of 8 is 2. 2 squared is 4. Seems scary. If you break it down into enough steps, it's not going to be bad. So the end, these are all the rules we came up with so far in this lesson. It's a lot to remember. The next 2 lessons are talking about this. Okay, I'm going to pick a couple from here. I'm not going to do them all on recording. I will show the work for them all so you can reference them. So let's look at let's look at A. So we get the square root of 25 all to the power of 3. So remember, the denominator is our root, the numerator is your exponent. Square root of 25 is 5. 5 cubed is 125. Okay, let's look at E together. This is a negative 8, so we have to be careful because that negative is there. So I get the cubic root of negative 8, all of that square. I can take a cube root of a negative, but I cannot take a square root. Cube root works because I end up with 3 negatives, which gives me back a negative. So this becomes negative 2 in brackets squared. So our answer is 4. Let's look at G. We have to remember our order of operations. The very first thing we do with our order of operations is brackets. So let's start there. So I'm going to get 9 plus 16. All of that is to the power of a half. 9 plus 16 is 25. then I get the square root of 25, so our answer here is 5. Okay, I want you to try the rest of these on your own. So pause the video, try them, and then you can check your answers with mine. Pause the video, that's really important. Remember, I'm not there to teach you and reinforce this. You have to make the smart choices. This is what's good for your learning. Okay, so looking at these, check over your answers. Again, if they don't make sense, you're always welcome to contact me and ask questions, but there's all of your solutions for you. Okay, let's turn the page over and let's work on some practice problems. So this question, again, we're doing it without a calculator. Remember, this whole unit is without a calculator. I'm only going to give you answers you can do without a calculator. That said, some of the workbook questions you may need a calculator for, just because they end up being good questions. Keep that in mind, but you're always trying to do it without a calculator. So this first one, same value, same numbers, except the second one has this lovely negative symbol. So remember from our last lesson, that means we reciprocate our fraction. So square root, because our denominator is a 2, so we get the square root of 9 over 4. I hope we remember that's the same thing as saying root 9 over root 4, which is 3 over 2. But we need to remember all of that is to the power of 3. So then 3 cubed is 27, 2 cubed is 8. This question is going to be the exact same process, but we're going to start out by flipping it. So I get 4/9 all to the power now of 3 over 2. And then you're going to go through those same steps, so I'm not going to repeat them. At the end, if you wanted to check, you would get 8 over 27. Evaluate these expressions using radicals. So that means give your answer as a radical. So these ones should be pretty easy. I get the cubic root of r. Power of 1, you may or may not want to write it, personal choice. The 7th root of s, I could say it's all to the power of 4 or just s is to the power of 4. The negative, so I'm going to reciprocate it. It's like it's over 1 right now. So then I get 1 over t to the power of a 6th, which is 1 over the 6th root of t. Okay, let's go on to the next one. All of these numbers are very similar. So we have 64s and 2s and 3s and all of these. A couple of them have negatives. So let's go through and simplify these. These are really good questions I'm going to give you. These ones end up being level 1, 2 questions, depending on the numbers, that being said. So this first one, I'm going to have the cubic root of 64. That answer is squared. This next one, I'm going to have negative 64 cubed, all of that squared. So both of those are actually going to give me the same answer because I'm squaring them, so I'm going to get a positive on both of those. C, the square root of 64, cube that. This last one, the square root of negative 64. All of that's to the power of 3. You cannot do this. So D involves the square root of a negative. Of a negative number, which has no meaning. It's actually called an imaginary number, which is way above us. With that, let's do class example 5, and I'll stop there. So a cube has a volume of 60 meters cubed, right? A power which represents the edge length. So remember, a cube, all the same length. So really, I just want to take the cubic root of 60, but it said a power, so that's 60 to the power of a third. Write a power which represents the surface area of the cube. So let's remember, surface area is equal to the number of sides, which is 6 in this case, times the area of each of those sides, which I could say is like sides squared. So in this one, we're going to get 6 times 60 to the power of a third squared, which then we can simplify that to be 6 times 60 to the power of 2/3. It's in a power, so we can leave our answer there. Use a calculator to calculate the edge length and the surface area. Plug those into your calculator so you can check if you would like. At the end of the day, our edge length is going to be 3.9 meters, and our surface area is going to be 92.0 meters squared. So here's your assignment for the week as well. Next class, you will have a work period as well as time to do some IXL links. So remember, our class periods are normally 70 minutes long. This video is about 16 minutes. So you have quite a bit of time to work on these, but if you didn't finish them, that's okay because our next class period is all for work.